All right. Let's get this train rolling. What are we doing tonight? Gonna try and set up a more interesting board. Right now we just have just a simple board. I think it's like 10 by 4 or something, 3 by 10. Not super interesting. You know, we got a nice little carpet in there. But let's get something a little more interesting going so we can add the walls that we created last week. In lieu of procedurally generating this, which would require building up a procedural board generator, which is essentially what we have, let's just build one by hand. So the code right now grabs all of these vector 3s, right? They're vector 3 integers, and just drops these prefabs into the scene. So what we're going to do is we're just going to hand place these and then hand set up the neighbors. So we can say like these two cells, despite being next to each other, they're not neighbors, so that we can stick a wall right next to them. And then later on we can do some more interesting things. So let's go in and stop it from auto-generating. Stop this guy from going. And then also, we could leave this for now. But let's build sort of a simpler board, and then we can get it wired up, code it, and expand on it if we ever finish compiling. Go into prefabs, grab our cell, drop it into the board. Let's reset its position. Oh, it is in the middle. There it is. All right. So I'd like to do something where there's a wall. All right. So I'm going to Control D a bunch of these 5, 6, 7, 8, 9, and just kind of slide them around. It doesn't really matter where they are at this point. I am Control left click dragging to get them to snap. So we can leave them on the grid, and then moving around isn't so janky. Because we're moving to the actual positions of the game object, right? They have a coordinate that's the center, and we're putting our pieces on that center. We could have these like all obscured and off center, but nobody wants to move out a board around like that. So I'm just slapping a bunch of these down just to make some space, because I definitely want to have a wall. And see a little preview. I think I'm going to make the ghost be able to move through walls, whereas the other more corporeal entities won't be able to. So a little fun feature for the ghost that it gets to move through walls, but only if there's a tile on either side. I think that's probably pretty good. Let's bundle these guys up. Create an empty. Call this cells, right? Organize these in here. That's at the center. Drop all these in here. And then what we can do is add another empty and say walls. And we have our wall prefab. Let's drop a wall prefab in. And you can see the wall prefab is going to snap to the edges, because we designed it, right down the middle. And then we can drop them also in between. So we can say like, let's make this look a little bit. So we can say like, we know that there's a space on the other side of this wall. Like these are neighbors, but they're neighbors through a wall. And the ghost can move along that, but like the players can't. Or like, this wall can spin. Something like that. Something fun. Aside from just the normal, normal, nothing moves through walls. So I'm just drop a couple of these in just for now, for the funsies. But now since we have all our cells already instantiated, we don't need to instantiate them, but we need to tell our data structure, like where are the cells? Who are the cells? So we need to go into our board and modify this a little bit. So we can say, give it a game object, and call this the cell container. Right? And then we can, instead of building, which we do in start, where is start? Oh no, we call build. When we build, let's get rid of all this. You know, bad idea to delete it, don't comment it, but we'll deal with that later. We can go through and go into the cell container. Ooh, come on. Cell container, and get components in children and say, give me all the cells, right? So this will give me a list of all the cells inside that container. Now I don't have to really link all these up, but to be able to give them like a more interesting, you know, this is a neighbor versus relying on their coordinates. Probably just gonna have to do it straight up by hand, or give this script, you know, like a neighbors. That'd be cool. We could wire it up in the UI. The only downside to that being, like, if I set this neighbor to go this way, I also have to set this neighbor to go this way. Oh, that could be even better. So then it's directional. So like this is a graph, right? And the directionalness of it could be like, oh, you can only go through a secret doorway one way. I think that sounds pretty fun. Let's do it that way. So let's say each cell has a list of neighbors, which is just other cells. Neighbors. I think that's spelled right. We'll just call new list of cells, right? This will get instantiated in the UI, but let's jump back to Unity, let it compile. Now we can go in here, and once this pops out, we can say, you know what, this one has 2 new cells. Let's lock this guy, and we can just drag in those 2. So 4 and what is this, 6, right? So we can link them up this way, and then do some like fun UI or editor GUI to say like draw the lines, right? So like we know that this one's connected to this one, this one's connected to this one. But I think we also need to know, do we need to know directionality? I don't think so. Like, is there ever going to be a need that we need to move north, right? You know, maybe the ghost, every third move, the ghost moves north. We can figure that out later on through, like, you know, grab all the neighbors from the cell you're on, find out which one's north, and calculate it instead of hard coding it. This might be a little more flexible. And we'll deal with our pathfinding later. Yeah, I think that sounds good. I'm going to hook up a couple of these, right? And then I want some visual feedback to know that these are linked. So let's get like 3 or 4 of them. This one has 3. We're just gonna 5 blank and 11 done. Unlock. So these 2 are hooked up, and let's hook up this guy. This guy has 3. And we could do this like we could do it procedurally, but that's going to be, you know, that is not the one I want to drag in there. 3 goes in there, 0 goes in there, and 11 goes in there. Okay, so we've got these 3 set up, but we have no indication that they're linked at all. So we can do something with the on inspector GUI. Let's see if we can pull up some docs. Inspector GUI. So I'm just going to Google the Unity docs. Everybody loves Unity docs. Yay. Let's see if we can do... it's not on inspector GUI. Is it just on GUI? On GUI selected? Maybe we can find it through the code. I'm pretty sure it's like on something. On Gizmos. On Gizmos. Let's do on Gizmos. So the difference between onDraw Gizmos and onDraw Gizmos selected is this will always run. So like every frame in the editor, this guy will always run. And then every frame in the editor while this game object is selected, this guy will run. So we could do like a highlight or something, but for now, we'll just iterate over its neighbors. Excuse me, and draw some lines. You know, do a little debugging drawing. So like neighbors for each, and then we're gonna say n for neighbor. Give it a body. So we're gonna draw a line from here to the selected neighbor. So it's debug, draw line, and then we're going to say transform.position, and the other end is going to be the n.transform.position. And then we could set a color. Let's set a color. Let's make them green. Green, and yeah, this is going to run every frame, so it'll just keep updating. And this will draw lines all over the place. Let's see what that does after this compiles. And there we go. So now you can see there's some debug lines in there that let us know, okay, these are hooked up. But we don't know the direction, right? I want to know, like, okay, is this one hooked up both ways? So let's signify that. Let's say we only draw halfway to it. So we draw the current cells transform towards the neighbor, right? So we're going to go halfway to the neighbor. So it's not the transformed up to position, it's the where you are minus, oh geez, this is going to be mathy. We need to subtract the vectors and then add back the original vector and divide by 2 some, I don't know. We'll figure it out. We'll say var, say var destination is equal to n.transform.position, and then we're going to subtract the transform.position, right? This is where I want to go and where I am. So this is like the move vector, right? And then where I want to go, so I have my move vector, and then I want to just, move vector, I want to shrink it by half, times equals 0.5, right? That's half. And then we say transform.position plus our move vector. Right? So this will take, go where we are to halfway, whatever our move vector is calculated, and that'll be our end position. And then let's pull this out into a variable because I want to reuse it. Yeah. Nope. Gotta highlight. Introduce variable. Transform halfway point. And then let's just make sure and say debug. Draw, what is it? Sphere, circle. Can I only debug draw lines? Oh, it's a gizmo. Gizmos are circular. So gizmos.draw sphere, and we want it at the halfway point, and we want it to be pretty small. Let's say 2f. Right, and we probably don't need to give it a color. Jump back into Unity. Let's see what happens. Ooh, nice. Nice spam. Boop, boop, boop. There we go. So now you can see we've got going from here to here, and then there's the circle there. We know these are going out. Maybe we don't need the circles. Let's get rid of the circles. Goodbye, circles. So now once we load this, all right, now we can see like, see how this line is complete? It means both ways are connected. Whereas these guys, only half is connected. So only half the neighbor is set up. And then as we go in and add the neighbors in, we can, those will automatically update. So we see 1, 2, 3, 4. So I'm just gonna grab this guy, grab this guy, grab this guy. Super fun to watch. Dragging and dropping. Now this guy's set up. So now you can see we've got this grid that we can move on. So we can traverse this graph by saying like, okay, I know where I am and I know who my neighbors are. So I can go to my neighbor and then I can go to my neighbor's neighbors. And therefore, as long as the graph is connected, like a connected graph being all the nodes are, you can reach them. We can get there. This is, I guess you could also consider this directed because like you have to have both ways, like forwards and backs, to be able to see, to move from node to node. But that's a little, I haven't taken a discrete math course in 10 years. It's amazing I remember that kind of stuff. Cool. So now we can go through, slap a bunch of these together, and decide if we want to, how we want to deal with this. Boop, boop, boop. This is 3. And this guy. I'm only going to set up a couple of these and then just enough of them so that we can move around. I'll probably just drop down to 1 player and 1 enemy for now. Just so it's not super duper crowded. 2, 3, 4. Yes. So the reason I'm doing this by hand, like the first time through this, doing it by hand, it gives you a feel of what the algorithm's going to be, right? I know that like this is the data structure I want. I don't have to deal with my like generation algorithm getting in the way of what my data structures are going to look like. It lets you kind of really feel out what sort of data is going to be flowing through the system, and get you a better feel of like when you do go to make this procedural, right? By doing this, 50 times in a row, like you can get a feel or a sense of, oh, there's a trick here, right? There's like, oh, if I'm this cell, I know that my neighbor cells are going to have offsets of a certain number or something like that. Just some little insight that you wouldn't really get when you're going into it procedurally from the beginning. And then once you do make it procedural, you've got all that initial learning out of the way. But I've got 8 of them set up, so we should be able to move within any of these 8 tiles, but then also you can move off onto this tile, right? This is an exit, essentially. But there's no way to get back onto the graph. I also want to move these guys down. If I move them down, like so they're below, right? Will that look too weird? Yeah, that'll look too weird. This is getting pretty busy, but we'll leave it for now. Let's get back to writing some code. So on the board, we build, and everything's based off of our cells, right? So we can actually just say var cell the cells. So let's get a list of all the cell children, right? So because we are grabbing this container, right, this game object, right, we're really grabbing the compile. We're going to give it the cells empty, and the empty, we can grab all the children that have a cell script on it. So it'll actually give us these game objects if we ask for all the children of type cell, or all the children components of type cell, even though we're up here. So we're gonna drop this guy here. Guess these guys can shrink down. We don't need the prefab anymore because we are not generating them at all. They'll already be in the scene. All right, so now we've got all our cells. We need to figure out what their vector 3 integer position, essentially their position on the board logically, and then we can modify like our movement coordinates, right? So instead of like get moves, we'll do like get neighbors, something like that. But then we can do the same thing, like the cells, we can iterate over these. Oops. This is a plain old array. For each in cells, the cells. Cell. For each cell in the cells, can I do this? It is... Alright, let's just to-list this guy. Can I? Because this gives me just a plain old array, right? Get components. So there's a pretty big distinction here. Get component in children, and it'll just grab the first one it finds, or get components with an S, and it'll give you an array of those. Now we can iterate over it because this is now an enumerable, a list, an array, and do each one instead of a singular one. Great. And the cool thing is when we set these up, their world position actually is going to be their board position, so that we can calculate like, all right, this is the -1, 0, or no, Y's up, -1, -1 board position. Like, I don't think the actual numbers matter. At this point, we can say like, all right, -1, -1 on the grid it's fine. It's just as valid as +1, +1, or 0, 0 as the start. So we can say cells, dot add, and we can say cell dot transform dot position dot we need to convert it to a vector 3, right? So let's do it very verbosely. Vec in position equals cell dot or we need to convert it. Vector 3 int dot, or can we just do new vector 3 int cell transform position. There's a loss of precision here, right? Going from a float. Nope. So we can do like x. Will that let us? Nope. Loss of precision. Float is not assignable. Let's see if there's a static we can use. Vector 3 int dot scale ceiling floor to int. We can do floor to int. And can I pass it? Yeah, a regular vector 3. Cell that transform position. So this is going to floor each component. So if for some reason we place one of these just off a little bit, it'll just floor all of them. Probably going to bite us pretty hard later, but let's not let perfect get in the way of done. So that is the position, and then we're just going to pass the cell. Right? So now we set up our dictionary with all of our cell coordinates inside of our dictionary, and we can still access them by coordinate. That should be okay. This guy needs to go above. And instead of positions.count, it needs to be, well, it can be nothing, but we can say the cells.length. So you could leave this empty. So this constructor, if you say, don't give it an initial size, it'll just grow. But since we know how many we need, might as well, let it know. And we'll get exactly as many as we need. We're not going to add or remove any during gameplay. We save ourselves a few kilobytes of space. Yeah, because this is the late 70s, and we only have 4 kilobytes of memory. All right. So I think we might, because these are on the grid, right? We can still get away with this. The only thing being, like this coordinate, right, is if we move forward, like there may not be a neighbor link there. Like this would still work if we had gaps to stop to stop moving through it, but we don't want to leave gaps. That's the whole idea. So let's say it has to have that cell in front of it, and that cell needs to be in the neighbors list. And cells, cells forward position, right? Because we already know it's there. Like this will explode, and because we're anding, it'll check this first. If it's not there, it won't even look at this, so we won't have to deal with null referencing. And cells.forward position.neighbors.contains, and then we need to give it another cell, which would be this cell, which means we need to get the cell. So we could just, yeah, let's just assume it's in there. You know, why not? Let's assume we're always coming from a good position, right? So this chords, we're only going to ask if we're coming from a position. That's a cell. So now if the forward direction exists and the forward position has a neighbor that is the current cell, then we'll add the forward position. I wonder if we could just... That would be having the directionality. Otherwise, we could just do return cells. Oops. This is a fun part about doing this, you know, from the hip. It's neighbors select. Is it select? Neighbor and then neighbor.chord. .toList. There we go. All right. So we're going to grab the neighbors, and this is just going to select all of the cells, and then, right? Select. Oh my, I am so bad at link. Is it select or is it select? No, select many flat maps. Select, and then where filters. Okay. So this is going to select all of them, and it's going to select the coordinate out of them, right? The integer coordinate. I'm just going to list it and return that. Bam. So we don't have to do all this. We just, one little link query, hopefully won't burn us. Hopefully. Anyway. This looks okay. This just clears all the cells. Let's see what we can highlight. Get the list. If the keys, yep, this doesn't matter because it's exactly the same. And let's go see if we can get the game going. Let's see where we drop. Get start position. Okay, so this is gonna 0 to. Okay, this is because we hard coded this. Yay! Remember when we said this was gonna burn us? It's about to burn us. Let's just do a single player for now. All right, we're gonna instantiate one player, and all right, we'll do two. So 0, it's gonna be whatever's in the first in the list. So, and we're guaranteed that nothing's there. Get open position. Let's make this 1 because this guy's gonna go to 0, 1 through 8, or let's make it a little bigger. You know, let's have some fun. Cells.length count. And we'll see if those guys get dropped in. All right, wrote a bunch of code, deleted a bunch of code. Let's watch progress bar and see if it still works. All right, we got our skeleton. The ghost is stuck. Okay, so the ghost got, yep, the ghost got dropped. So because we're using get children, it's getting all of these, but not all the neighbors are set up. And you can see key not found. So it was trying to find a neighbor. It doesn't have a neighbor. We're gonna have to either delete a whole bunch of these or set them all up. Let's Let's delete them. But I didn't. Where's? Okay, so you can see I'm like I keep selecting the canvas, right? Because the canvas is a giant game object. Here, we'll just zoom to it. So here's the canvas. It exists in the world, but like it's huge, and it starts at 0, 0, and it gets in the way. So what you can do is go into one of these guys, and that's not it. Oh, here it is. So if you go into the gutter, into your hierarchy, there's this eyeball and this finger. If you unclick the finger, it'll still show up in the scene, but you can no longer select it. You have to come over here to select it. And if you hit the eyeball, it's not even, you can't even see it in the scene anymore. It's still there. It's just totally gone. So if I'm not working on the canvas, why would I ever want to select it? We could do the same thing like directional light, not going to use it. The volume, not going to use it. We could do the same thing with the board, right? Just get rid of it if we're working on some other piece. It's pretty handy if you start getting a lot of overlapping game objects and colliders and meshes, and you can just stop stuff from getting selected. You could even go in and like get the subset of things and stop them from being able to be selected. Let's see if I can get that to happen. Boop, 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 boop. Nope. Oh, yep. So now when I try and select this, I only want to be able to select one of these. Something with a collider? No? I don't know. It has to be something visible. Let's leave it off. All right, we got too fancy. We delved too deep. We'll just leave them all selectable. But sometimes you'll select like a sub-object and it's a pain in the butt. That's for another time. All right, let's get rid of a bunch of these guys. Boop. And guess what? Let's just set these last 4 up. Should only take a minute, right? This guy has 2. It's this guy and this guy, and you can see my console's exploding because I deleted a bunch of stuff and it was still like trying to render things. It's cleared up now. This guy's got 3. 1, 2, 3. Lock. Grab you. Oh, it's because it's trying to draw these 3 empty ones. You can't get null to it, so we'll fix that. We'll fix that in a second. Get those null references to stop exploding every time we select something. That guy set up. Let's do this guy. This guy has 3, which is you. This is super fun, you know, dragging and dropping, just dragging and dropping. All right, got those 3 and one more, and you can see like, oh, which one didn't we do yet? Oh, it's this one. Let's set that one up. Just super handy for just draw stuff in the scene, and it'll help you figure out, you know, what you have left to do. Ooh, I dropped that in the middle. What you haven't done yet, you know, what things are connected to what, and it works while the game's playing. So like if you have 2 things connected that you want to like track like a vector between them, or like the direction they're moving or their momentum, you know, anything like that, you can do these little draw lines, and it helps you track stuff. Let's save and let's fix these guys. So writer, Undraw Gizmos. Where'd it go? This is, I want to be in cell. So it's trying to draw a line, and this is getting nulls in it. So as long as if n equals null, continue. Tin break, continue. Return? Yeah, hopefully. So if it gets to 1 in the list that's null, it'll return. I don't know if this, like, I want it, it's a loop, so it should be continue. But it doesn't like that for some reason. If n is null. All right, let's do it the other way. It's just I don't trust you know, inside of a link command. I guess it does call it on each one. Or let's see what this does. Let's see what it inverts to. Return. All right. If n is null, you know, if there's nothing there to draw to, don't draw anything to it. Done. Oop. So now we should be able to avoid all this null reference whatnot. So if I add another one, make it none, right? So none is essentially null. And I select it, like there's no mass of null pointers. Cool. Let's run this guy again. Oh, that's good. Yeah, these guys are way out there. Wonder why. See if we can figure it out. Key not found exception. That's weird. Probably because of an order of operations. So the board is at 0. The cells is at 0. So these are the world positions. The coordinates map to the world positions. Let's see why. Why are you angry? Get moves 64. Does coordinate get set up? Yeah, I don't think chord ever got set up. Let's go take a look. Cell. Yeah, we didn't set these guys up. So let's go in here and set them up. We'll just put a little getter in. And get. Oh, come on. Come on, properties. Generate. Nope. Refactor. Oh, geez, I forget how to do this. Let's track. No. I want to generate property. No. Not event functions. Getter, setter, constructor, reader, properties. All right, generate the chord. Public. Okay. There we go. Oh, this generates another one. So like this could be private, right? So we can say vector 3 get new vector 3 transform.position. Maybe. Doesn't like that. How do we do it before? Oh, we use the static. Vector 3 floor to int. There we go. So there is no setter. Can we just rename this guy? Whoop. Chord. There we go. And it's probably mad because of, yeah, the naming. What are you mad about? Ooh. Why? Expression bodied property. All right. Fair enough. I guess if we only have a getter, we just do an expression. This should now, so now chord represents whatever the coordinate is. So if we decide to change this later, we'll have to switch to everything using that chord property. But I don't know. Let's see what happens. See if we can get back on the board. Nope. Maybe? Yes? Ooh, we have some new reachable code. Oh yeah, we do. Yeah, why are you guys way over there? What are you doing? Alright. Something about how those guys are instantiated. Oop, double clicked. Let's see. Player get board, get start position. Return positions 0. Oh. Oh. What do we do? Oh, because it was grabbing out of these. We're using cells. Yeah. All right. So we want cells. Oh, we need a name, right? So we can say, let's do this. Position 0. How do we declare one of these cells as the start position? We could just say positions 0 equals cells dot first. We should probably not use that because it's empty. The cells first chord. So we'll just grab the first position, right? And then get open position. Grabs a random one of those. Let's change this to cells. But then we can't do a range option because we need like a random vector 3 int. Right? And then we need to know more about the board itself. So we can do this. Since we're hard coding this and we already have this positions thing, wait for you to rebuild. Yay. We're gonna nuke like all but 3 of these. Oh, we clicked too fast. We're gonna nuke all but 3 of these. Boom, boom. Can I? Yeah, there we go. Alright, and then we're just gonna pick a couple. So like this guy in the corner is gonna be -1, -1. We'll do -1, -1, 0, 2, and 1, 1. Alright, everybody remember those? Great. -1 and -1 will be the start position. 0, 2, and 1, 1. Alright, so this will be the player start position, the skeleton, and then the zombie. Let's see what happens. Did I update? Yeah, I did update. Let's see what happens. There we go. We're back on the board. Can we move? Out of range? Excuse me. All right. We're getting closer. Doing some debugging. So cells.count, this should be positions. All right. Give me any other position except for the first one to be an open position. One more time. Hopefully, yep. Oh, look at that. All right. Ghost. Player. Ghost. Player. They really like picking the ghost. Player. I should probably move him here in case the skeleton can move. Player. Ghost. Player. I should move him over there. Let's see if we can corner. Ghost. The player's too scared to move. Alright, move him off. Move the player. Sweet. We are back in business. For some funsies, yeah, let's move these walls over. Boop, boop, boop. And we'll just move this guy out. Let's just delete this guy. Shift D, Control D. I'm gonna move these guys back here. Why is that one already? Is this one already updated? Oh, because I duplicated it. Okay. These need to get fixed. So this guy is going to have this guy as a neighbor. Boop. And this guy is a neighbor. Nice. And then this guy is going to have this guy as a new neighbor. All right, plus again. New neighbor, 12. Great. And then this guy is only going to have one neighbor, which is this guy. Boop. All right. So now we've got this like little like we've got a wall. Yay, wall. All right. Let's see if we can get around the wall. Ooh. Send the ghost over there and the player. Skeleton's gonna go party over here. Player, ghost, player, ghost, player. All right. The skeleton. All right. So now you see the player can only move to this spot. Only this spot's highlighted. I can't move out here because there's no link there. There's no neighbor. You go boop, and he can move out again. And later we can implement the ghost. Moving through walls, but we've got a new tile system. Awesome. Sweet. It didn't take too long. Got some fancy walls. Let's do a let's update these walls a bit. So last week when we modeled them, we did a lower and an upper, and I want to be able to like fade this upper wall out. This is not. I am locked on something I don't want to be on. There we go. I want to like hide this upper wall, right? When the camera occludes, or when whatever's behind it gets occluded. And so we're just going to shoot a ray out from the camera and say, hey, are you a wall? You know, I'm gonna hide part of you. So what we can do is if we put this right on just the upper wall. Yeah, let's just put it on the upper wall. Is we ever gonna hide the lower wall? Let's give it a box collider. Bam. So we can see there's a collider on here now, and we can stick it on a layer. And layer. Wall. And when we mess with this upper wall will just be on the wall layer. And then we can like raycast. And if we hit a wall with a raycast coming out of the camera from like whatever we're looking at, we'll just hide that. Right? And then I don't know. How do we unhide it when it exits? We'll figure it out. Figure it out later. But that means we need to update our wall prefabs with. Let's just do it on this one. Do we add it on here? No, I added it on this guy. Overrides. So I edited one prefab. So I want this change to apply to all the prefabs of that type. So I can go into overrides, just say apply all. And now all of the walls will have that layer and box collider set up. So I don't have to go through all the instantiated ones and edit them. They just get it, which is sweet. Where is my camera? Main camera. We'll call this wall hider. Wall hider. Yeah. And I want this on the camera because the camera moves, right? It rotates and moves around the environment. And we're gonna give it a public layer mask, wall mask, mask, wall mask, and then every frame we're gonna say new ray. Ooh, I'm gonna have to remember how to do this. We did it in here somewhere where we shot a ray out and poked at. Here we go. Mouse ray. Same idea. We're gonna steal our own code. Update. All right. Mouse ray. Camera main. Screen point to ray. Why is this gray? Probably because it's wall mask. Let's comment these guys out, get back to compiling, see if we can get this to not be so angry at us. What did I do to this script? pasted something that doesn't like being in here. Oh well, fix it in a minute. There we go. All right. So we don't care about the button. We're going to do this every frame. So if we raycast the mouse ray and we have a hit info and we hit the wall mask, then we can say the thing we hit, get the component. We don't need to get the component. We just need the game object. We're just going to turn the game object off and delete this guy. Boom. Actually, we can just do it one line. Let's not even worry about it. Let's just turn them off. Game object dot enabled active set active false. Right now we're just gonna turn them off. Like we're gonna indiscriminately turn walls off, never turn them back on. Don't worry about it. That's step one. Just goodbye walls. Let's see if we can. And that's I'm shooting from the mouse, aren't I? That's all right. Let's see. So, nope. Oh, you know what we didn't do? Didn't set up the wall mask. Wall. There we go. Let's see if we can pew pew some walls. Pew pew pew. Great. That is fantastic. So now we can turn them off. Let's see if we can figure out a way to turn them back on. This is the tricky part. You know, tearing down walls is the easy part. It's, building them back up is not so easy. Oh, also, we just want the center of the screen, right? What is it? A vector 3. It's like half, right? And it's a 2D. Vector 2. It's 1 times 0.5f. Did you know multiplication by a half is faster than division by 2? In some architectures, probably not anymore, but back in the day, I thought that was pretty interesting. So vector 2.1 is just a 1, 1 vector, you know, in the X and Y on the screen. And we just want the center. So I just multiplied that vector by a half. Screen point right in the middle. Shoot that ray out. See if this works. I think it's 0 to 1 on the screen. It's probably not. Nope. It is not. Screen point to ray. There's like, we're gonna have to pull like the camera main. It's not aspect. Let's see. Velocity. No. Float. Vector 2. Lens shift. No, that's not. Sensor size. I don't think that's what I'm looking for. Vector 3. Nope. Transparent. I'm looking over here at the return types. Looking for like a vector 2, vector screen to viewport. These are all methods, which is probably not what I'm going to want. It's going to be one of these. It's got to be aspect? Rect? Is it the rect? Where on the screen is the camera rendered normalized? Ooh, nope. Focal length. Pixel, here we go. Pixel width. How wide is it? Okay, that works. So let's say var cam center equals new vector 2 and camera dot main dot pixel width times 0.5 camera dot main pixel height times 0.5. There we go. That should give us a vector right in the middle. And we can just do this and start. Not static. start, private, vector 2, screen center. Oh, I called it camp center before. That's all right. Boop. Boop. Calculate it once, reuse it. Hopefully her screen doesn't change size. That would be unfortunate. Give this a try. Boop, boop, boop. Watch a couple more things. Take a drink of beverage. Oh, look, it disappeared. Let's see if we can get it to disappear again. So the camera is pointing straight at like his feet. So I'm guessing if we move here, it might have moved too fast. Let's see if we can get the ghost or something. Get a little closer. All right. So now when we swing around, we should make these two disappear. Boop. Boop. Awesome. I am excited. Now we just have to figure out how to get them back. I think we might have to dig a little deeper into the physics system. So the physics system gives us things like on collision enter and on trigger enter. And we might just have to stick a collider on the camera and do something like that. Yeah, let's do that. And then we can block off. Like, let's create an empty and say like wall killer base. Go take a look at this. So since this is zeroed out, it's always going to be facing the same way as the camera. There's the local. And I can just add a box, right? This will give us a little more like width to hit walls with. I'll just make it super long. All right. We'll narrow it up to size. Let's make this 0.2. Make this a nice round number. 10. All right. So now this is our, instead of having a ray, we're gonna have this guy. We'll make it a trigger, and we'll put this on the wall layer. So now walls can only collide with walls. Physics. Wall cannot collide with any of this, only with wall. So it's what are those puzzles, those cross puzzles, like those logic puzzles? So you do those all the time. Only if the box is checked between two things intersecting. So now a wall can only collide with a wall. Drop that back. Now we can say wall collider, and I'm gonna move that script. So now instead of this being on the camera, I'm gonna move it up so we can get all of our events, and say on trigger enter, I think it is, on trigger enter collider, we'll just debug log and say I hit a wall, yay. We're gonna comment this guy out. Guess we can get rid of this guys too. Bam. Let's just see if this works. Because we know our wall killer is on the wall layer, and our upper walls are also on the wall layer. Nothing else is. So nothing else should collide. And I think it's on trigger because I set this guy as a trigger. Let's see what happens. See if there's some magic in there. That's not gonna work because we need a rigid body on one of them. Because we need this to be in the physics system. So we're gonna say, don't use gravity. It's kinematic, so we control it. Just lock everything. This thing is not allowed to move. But it can move as long as its parent moves. So relative to its parent, it's not going to move. Right, so you can see, oh, I hit a wall. Yeah. All right. Let's do the other one on trigger exit. And we can say other dot. We don't want to shut it off, because if we shut it off, it's not going to be colliding anymore. We're going to get its renderers. Get component, mesh renderer. Right? Mesh renderers, that's where they are. Let's double check. Because these are pretty simple objects, right? It's just, there's no children or anything. We can grab upper wall and just like boop off the mesh renderer, but the collision box is still there. So we can turn this off and on to show and hide, or we can do something fancy like fade the material, but let's do something simpler first. Get component.mesh renderer set active, enabled equals false, and then when it leaves, boop, we're going to re-enable it. So this is going to give us the, you know, when we're not being occluded anymore, re-add the wall. Hopefully. We will see. Let's clear out our console, give it a run. Let's see what happens. Oh, one already disappeared. There's another one. Yep, and they're reappearing. Nice. Ooh, excuse me. Gotta take a drink of my soda. Nice. So now we can see through it, and we will always be able to select, like, no matter where we're looking. I guess that one's. Let's fix that. So I can't. It wasn't letting me select this. So let's make our wall killer a bit wider. Edit, grab this, and we're just gonna just totally just make this. Let's not make it that wide. Let's see what happens. So I just made it wider so that it will make the neighbors' pieces disappear as well. So like the way we should be doing this is like drawing a line to each position, right? And then occluding anything that, or unoccluding those positions. But I think this will work. All right, still get a nice fancy, you know. This is it's a little excessive, but that's all right. I do not mind. Perfect. Dunzo. Should we do something fancy? Should we make them fade? Do you want to make them fade? I think we should make them fade. How about that? So last thing for tonight, we're going to make these mesh renderers fade out and fade back in. So we're going to do that with a coroutine. And those are I enumerators. Fade 2, and then we'll give it a int alpha, or float alpha. Maybe, I don't know. Yield return null, so this runs every frame. So when we enter, we are going to, we have to track, like, is it already fading? Right? Is it already fading in or fading out? This is going to be trickier than I thought. Let's think about this. So every time we collide with one, we want to start it fading out. But if we exit it before it's done fading out, it's still going to be fading out, so we want to stop that coroutine. So we're going to have to keep track of that. So let's just keep track of it. Game object and coroutine. Faders. There we go. I'm gonna get rid of this. It's not static. Start. So we're going to say faders equals new dictionary. So now every time we start one, we're going to check to see if it's already doing something in here, right? And if it's doing something, we'll stop it and make it do the other thing, you know. Yeah, that sounds reasonable-ish. Yeah. So let's see if faders dot contains key, and we'll say other dot game object. So if it's already in there, then we can say stop coroutine faders other dot game object. All right, so we stop it from doing it, and then we'll start coroutine fade to, and we're going to fade it to, because we're hitting it, we're going to fade it to 0. And this we can do faders dot add, or no, we know it's already in there. We can say we don't know it's in there. So if it does contain it, stop it, start the new one. And then if it does contain it, else. If it doesn't contain it, add it. Yeah, faders.add. Other game object. And then start the coroutine fade to 0, right? So if it's in there, stop it. Otherwise, stop it, and then we're going to add the new one. And then if it isn't in there, we're going to add it. And then this one, we can just say faders other game object equals, right? Because this is going to return a coroutine. And it'll just store it, because either way, if it's in there, great, we'll just stop it. If it's not, we'll add it. But this is going to start it. So we don't want to start it twice. Yeah. All right, we're writing the same line of code twice. I guess this isn't the same line of code twice. It's very similar lines of code. Great. So if it's in there, stop it, fade it to 0. If it's not in there, or if it's not in there, add it and start the coroutine. So this is doing two things. One line of code does two things. Fantastic. And then on trigger exit, we are going to do the same thing. I know. Just copy and paste that code. And we're going to fade to 1. All right. And then in our fader, we could say while. I guess we got to tell it what to fade, right? Material and fade it. So while the material dot color, right? Color dot a is not equal to the alpha we want to go to, then we're gonna do it. We're gonna move it. Mat dot color dot lerp. No, we want just color dot lerp. I feel like the music just got real loud. Turn it down like a touch. Yeah, there we go. At least it got loud in my headphones. You guys let me know if it's too loud in your headphones. We are going to lerp from the current color to the color we want to go to. So this is basically from white to clear, right? And it depends on what the alpha is. So color 2 equals, if alpha is, all right, I guess we could say color.white. I mean, we could just do color white. white to clear and go the alpha distance. So if we want to fade it to like half or full or 0, we can do that. And this will let us do it from anywhere. So if we stop halfway through or halfway to where we want to go, we'll go that direction. So we want to go the matte color, color 2, and then we want the lerp to be in the direction of the alpha, the direction we want to go. So let's see if we can lerp from where we are to where we want to go. How fast do we want to go there? Let's say 0.1f. Bar lerp AMT lerp amount. Right, so this will recalculate, you know, how far to each color we want to go, and hopefully we'll get to where we want to go. Let's see. This is our destination color. And we want to go from whatever color we're at towards the alpha. So this will go up or down. But I think it's going to go faster one way. Ugh. Let's give it a try. What's the worst can happen? It'll explode. Ooh. Oh, yep. Probably should pass it, the thing. Bar other, what do we do? Material, other mat equals other dot game object dot get component mesh renderer dot is it shared? No, it's just material, right? It'll just give me the one first instantiated material. So it's not gonna light up all of them. Same thing here. Same thing. Other map. Fade 2. We're just going to pass this around. Well, not around, but pass it where it needs to go. Let's see if we can get this fading. Call it a night. Go take a nap. Watch some progress bars. Ooh, uh-oh. Routine is null. Alright, let's see. 27. Stop code. Oh, so if it finishes, right, it becomes null. We got to handle that cases because the coroutine just exits, right? So it containing the key really doesn't matter. So if faders other dot game object is not equal to null, then stop it. Right. So if it stops, this becomes null, but the key is still in there. It's a good time. Let's copy this guy out. So despite containing the key might not be active being used. One more time. All right, it's not null pointing. It's also not fading. Let's see if we can. This one's definitely hitting it. Let's see if we can see if the material's changing. So this alpha would be changing. Nope. Time to do some debugging. Matte color, This will change it. Let's see. See if this is actually running. Debug.log lerping to. Let's just add lerp amount. Maybe my lerps are off. I lerped my lerps too many times. It's probably an easier way to do it. Probably a way easier way to do it. But this is what we got. This is what we got to work with. Some progress bar is going. It's lerping. Probably just super slow. Let's see if we collapse these. Boom. Yeah. They're all, yeah, look at it. It's all just a 0.9. So let's do a little bit more a little more verbosely. The start alpha is going to be the mat.color.a, and then the target is the alpha. Color 2 lerp amount is going to be whatever the A is. Yeah. Are we just not? Does it just needs to be the other end of the lerping? Try that. If it ever builds. Oh, clicked it too fast. Yeah. Huh. So it's lerping. It's like to some tiny amount. But maybe we're not calculating it right. So we're only going 0 to 1, right? Fade it to 0. So let's switch it up a bit. Let's say color. Call this the destination color. And instead of passing 1s and 0s, we'll just clear. Make it clear. Clear. And we'll make these white. Because the actual color in the object or in the mesh is being taken care of by its texture. And so now we can do while color is not equal to destination. Okay, let's get rid of this. Let's clean this up again. Let's start fresh. All right. So while the color is not at its destination, then the material dot color should equal color dot lerp, and we go from whatever it's at to the destination. Let's go 0.99 and 5. It'll go fairly quickly. And it'll yield. It'll boop boop boop. Keep flipping until it gets there. Until it gets close. Ooh, yeah, because this means it has to be exactly that. We'll do this. Var amount. And we'll say it's going to take 1 second, right? While amount is greater than 0. We'll do amount minus equals time to delta time, right? And we're just going to do it this way. So it'll go from 1 to 0, 1 to the other, over time. Don't have to worry about this lerpy, partial lerp, whatever. Cool. And let's throw a debug in there. Let's say, whoa, too many, not enough. There we go. I'm lerping amount. Spelling's hard. Oop. Back. Watch some progress bars. Run. Run again. It's doing something. See, they're changing. Alright. So maybe passing the material? Like, does this work? Let's move this down. And we'll do it in here. Right? And instead of we can say game object. Oop, delete space. All right. All right, we're gonna get the component out of the object, mesh renderer, material. Oh, I wonder if we... Oh, that should be equivalent. Hopefully that's equivalent. Could they all be fighting? Like, because it's not shared material. Shared material is like the material of all of them, like the main material. But this is let's give it a try. Change this guy to game object. Change this guy to game object. Right, shoving some code around. So hopefully this, I don't know, doesn't make a copy, modifies the copy. Fade to 1, fade to 0. So wherever it's at, whatever color, fade towards it. All right, that's, you know, if we start in the middle, it's going to take a second to get the edge, versus if we start the one edge, it'll take us a second to get to the other edge, or the other color, not edge, color. Why does it look like it's fading in here? Oh, that's just how it looks. Material instance. The color. Like, does this not? Oh, why is that not? All right. Well, my understanding of this is wrong. Oh, probably because they're all opaque and they can't be transparent. Materials, house, opaque, transparent. Let's try this again. So if they're opaque versus transparent, they're in different parts of the render queue. Yeah, you see they're sort of changing color. Something's happening. No? No. I guess not. An attempt was made. Let's swap these guys back to just hiding. Just be alright. Just let it hide. Let's just, yeah, this is interesting, but ultimately figure it out next time. So once we enter, we can say other dot game object dot get component dot not mesh. What do I hit caps? Get mesh renderer dot enabled false. Excuse me. Just need to steal this line of code. True. Back to the boring old snap in and out. Yeah, that would have been kind of cool, right? I'd probably use like some shader tricks, you know, do things like that. But this will work. Oh well. You know, don't let perfect get in the way of looking amazing. Oh wait. Yeah. So I got some walls hiding. How about we just go through, build a little more walls just to see what it looks like, and be okay with that. Let's move this guy over. Rotate him 90. D. Duplicate. 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 Ooh. Build up our house a little bit more. Let's see if we can oh, I didn't need all those. That's right. Yow. Boop. Get rid of you. Grab these three guys. Duplicate. Duplicate. Just walling everything in. With our little secret alcove. Right? Also, I want to make this opaque again. I do not know why those have turned gray, but there we go. It feels a little bit nicer-ish, I guess. I want to actually one more thing. Let's swap out. Where's the camera? Let's swap that box collider out with a capsule collider. Remove component. Go find our capsule collider. Make it quite a bit taller. And this is going to go along the z-axis because that's what the forward is. And maybe we can just make this look a little bit better. Just make sure it goes through the ground. Turn the radius up. I don't know, what do you think? We want it to hit, so if we're in this position, we want it to hit all of these. Yeah, 1.5. That works. So this will get rid of like some of the like weird, you know, you saw one of the corner pieces popping in and popping out. I did not make that a trigger. Oop. So like it'll be more natural, you know, circular, you know, like this piece isn't popping out as much. You can see like these guys are going away. Boop. It's kind of feeling more like a house, housey thing. Yeah. Maybe get these guys not to cast shadows. Cast shadows off. Bam. Now we can do like some internal lighting and the walls won't cast all those weird shadows. But I guess now the players are all casting weird shadows. We can move that directional light, do like some internal lighting. You know, put like a little candelabra up there. Get some real-time lighting going. Global illumination. Yeah, make everything look awesome. Oh no! Oh. Still too scared. Ah! No, we're just gonna keep moving the ghosts around. So this is like the situation where you're playing the game, you know, you get stuck underneath a monster and can't go anywhere. Alright, let's run away. Neat. I think we're gonna call that good for tonight. We got a lot done. We got a cool new sort of board mechanic. You know, we can define what our cell's neighbors are. Not procedurally generated, but you know, that's okay. Um, got our movement system hooked back up fairly easily. We got the walls in. The walls getting hidden. Unfortunately, couldn't get them fading in and out. That would have been pretty cool. But we still get the base there. It looks all right. Um, and yeah, this is really coming along. It's starting to look like a half decent board game. I don't know what we're gonna do next week. Uh, throw a subscribe down, and we'll figure that out next week. Have a good week, everybody. See yous.